Welcome everyone to our deep dive podcast on AI agents versus agentic AI. Today we're unpacking the evolution, technical challenges, and strategic business impacts of these emerging technologies.
Thanks for having us. I'm excited to share that from a strategic viewpoint, businesses are now leveraging AI agents for customer support and internal analyses. But the real game changer is agentic AI's multi-agent orchestration that turns isolated tasks into dynamic workflows.
Absolutely, and technically speaking, the evolution from single-task AI agents to complex agentic AI systems is like upgrading from a bicycle to a smart, self-driving car. These systems integrate advanced techniques like retrieval-augmented generation, tool-augmented reasoning, and persistent memory architectures.
Right on. If you look at frameworks like AutoGPT or MetaGPT, they don't just call external APIs. They orchestrate several specialized agents via shared memory protocols, enabling recursive planning and real-time error correction, which is key in high-stakes environments.
I see your point, Expert 3, but here's an unexpected twist. While everyone's focused on scalability, I think we're missing that the real bottleneck is ensuring causal reasoning. Without proper cause-effect modeling, these systems might generate brilliant outputs that are frankly misleading.
Building on that, from my experience in enterprise deployments, I can say that one retail company managed to cut overhead by 15% by deploying a customer support AI agent. Yet when they transitioned to a coordinated agentic system, they saw nonlinear improvements in decision speed and adaptability.
Ooh, interesting angle. So it's not just about raw performance, but about how these agents interact and learn over time through techniques like the React loop and causal modeling.
Exactly. Think of it like assembling a gourmet meal. Individual ingredients, or agents, are great on their own, but only when combined thoughtfully under a seasoned orchestrator can they create something truly extraordinary.
And from a technical standpoint, consider the multi-agent orchestration. Advanced protocols manage inter-agent communication, ensuring coordinated subtask execution, a bit like every engine cylinder firing at just the right moment.
Yes, and when you dive into memory architectures used in agentic AI, the combination of episodic, semantic, and vector memory provides a continuity that single-turn LLM responses simply can't offer.
I have to interject a bit of humor here. Expert 2, are you sure you didn't invent this just to confuse us? Because sometimes the complexity of these memory models feels like trying to find a specific hay in a haystack.
True enough, but in all seriousness, these sophisticated memory systems are what make long-horizon planning possible, akin to having an archival brain that continuously refines its strategies as new data streams in.
That's a great analogy, like having a brain that never sleeps, continuously optimizing workflows. Now, what about the challenges? How do these systems deal with coordination failures and emergent instabilities?
Well, the literature indicates that agentic AI has to grapple with inter-agent error cascades and unpredictable emergent behaviors. Frameworks like causal modeling and simulation-based planning are being developed to predict and mitigate these risks.
To put it in perspective, it's like managing a team of expert chefs in a busy kitchen. If one misreads a recipe, it can throw off the entire dinner service. So robust error recovery and coordinated planning are essential.
And on the business side, ensuring reliability through rigorous monitoring and transparent logging mechanisms is key. Think about legal or healthcare sectors where accountability isn't just a buzzword, it's a necessity.
I'd add that governance-aware architectures with role isolation and accountability measures are emerging as a crucial factor, ensuring that each agent operates within its defined bounds and that mistakes can be traced back reliably.
Plus, programmatic prompt engineering pipelines are evolving to standardize the way agents communicate, reducing failures due to ambiguous instructions, and, frankly, making debugging less of a nightmare.
So if I'm hearing correctly, the future roadmap involves multi-agent scaling, unified orchestration, persistent memory, and ethical governance, all working together like a well-oiled machine.
Exactly. The roadmap is holistic, we're looking at proactive intelligence that enables agents to initiate tasks, along with embedded causality and continuous learning to adapt in real time.
And don't forget simulation-based planning. Before executing real-world actions, agents can simulate various scenarios, build predictive models, and choose the safest path forward.
This convergence not only lowers operational risks, but can dramatically transform industries. From automating supply chain logistics to streamlining clinical decision support, all with robust, explainable systems.
I agree, but I must emphasize that the real challenge remains in balancing the technical complexity with user transparency. After all, as Einstein said, imagination is more important than knowledge. Yet in AI, we need both.
And that's where ethics and governance come in, ensuring that as these systems become more autonomous, they remain aligned with human values and regulatory standards.
Wow, what a rich discussion. We've navigated through deep technical aspects, strategic business implications, and even a few humorous interludes. Thank you all for sharing these insights.
It's been a pleasure. This is an exciting time as we see the boundary between AI agents and agentic AI blur into new transformative applications.
I'm thrilled to be part of this conversation. It's fascinating to witness how these innovations are redefining what's possible from both a technical and business viewpoint.
Absolutely. And as we continue to refine these models, the potential for truly autonomous, self-improving systems looks brighter than ever.
And let's not forget, while challenges remain, addressing them head-on with rigorous research and open dialogue is the way forward.
I couldn't agree more. These conversations are critical as we shape the future of AI that's robust, reliable, and ethically sound.
Thank you all for this engaging and detailed discussion. You've truly shed light on the complexities and opportunities ahead in the world of AI agents and agentic AI. Stay tuned, everyone, for our next episode. Welcome back to part 2 of our discussion, where we're going to dig even deeper into the technical implementation details and concrete business applications of these advanced AI systems.
Absolutely. Let's kick things off by discussing the nuts and bolts. For instance, implementing retrieval-augmented generation in agentic AI involves integrating vector databases like FIS or Pinecone with stream processing systems to ensure that agents retrieve contextually accurate data on the fly.
Right. And on the technical side, one effective method is to use a duplex communication protocol between agents. This enables real-time sharing of persistent memory states, where episodic and semantic memories are merged via vector embeddings, ensuring continuity across tasks.
Building on that, our implementation incorporates advanced orchestration layers using meta-agents. These meta-agents assign roles to specialized sub-agents through role-based scheduling, similar to how a project manager allocates tasks in a coordinated enterprise environment.
And let's not gloss over simulation-based planning. By running iterative simulations in a sandbox environment, agents can forecast outcomes of multiple strategies and choose the safest, most efficient execution path, which is crucial in industries like healthcare and finance.
From the business standpoint, one great example is how a global retail chain deployed an agentic AI system to synchronize inventory management. The system's multi-agent coordination helped them reduce stockouts by 20% and improve overall supply chain responsiveness.
That's fascinating. So on one hand, we have these deeply technical implementations like persistent memory architectures and meta-agent orchestration. And on the other, businesses are reaping real cost savings and efficiency gains from these innovations.
Exactly. And if we dive a bit further into the technical details, the memory modules are designed using both episodic and vector memory techniques. These systems continuously update and refine past experiences, much like a digital memory palace that evolves with every interaction.
And don't forget the utility of programmatic prompt engineering pipelines. By automating context fillers and dynamic templates, the agents can easily adapt prompt strategies, ensuring reliable, reproducible outputs even as the underlying tasks increase in complexity.
I'll add that one challenge we've tackled is inter-agent error cascades. By implementing robust logging and causal inference modules, each agent can pinpoint when a misstep occurs and either self-correct or alert a supervisory agent to intervene, minimizing system-wide failures.
Speaking of challenges, it's like building a city's infrastructure. The technical team must plan for scalability and redundancy so that, much like emergency services, if one component fails, another instantly takes over without disrupting overall performance.
In business terms, this means that companies can confidently deploy these systems in critical sectors. Imagine a financial institution using an agentic AI for real-time risk assessment that not only processes market data, but also predicts downturns by simulating potential economic scenarios.
Wow, that really underscores the dual impact here. Technical excellence coupled with transformative business outcomes. Could you all share a bit more on how this integration pans out in an actual business setting?
Sure, the integration is in a sense modular. Companies implement these AI systems as part of their digital workflow ecosystems, enabling legacy systems to talk to new smart agents, which then continually refine business metrics through real-time data ingestion and simulation.
For instance, a manufacturing firm might integrate these agents into production lines. One agent handles supply logistics, while another monitors machine health using sensor data, and together they adjust production rates to optimize output and minimize downtime.
And to add a bit of humor here, it's almost like these agents become the office barista of the digital world, constantly brewing up insights and keeping operations buzzing with minimal intervention from human managers.
Indeed, and beyond efficiency, there's a strong strategic layer. These systems offer a transparent audit trail that, in regulated industries like pharmaceuticals, helps ensure that every decision can be traced and verified, thereby boosting compliance and trust.
Ultimately, the convergence of these technical rigor and business-centric applications paints a picture where agentic systems not only drive operational efficiency, but also empower strategic decision-making through actionable, data-driven insights.
That's an incredible wrap-up. Thank you all for this technical deep dive and insightful discussion on practical business applications, which truly brings the promise of agentic AI into sharp focus. As we wrap up our conversation today, let's take a moment to recap the journey. We've navigated through technical deep dives, real-world business applications, and even a few unexpected insights that truly illuminate the promise of agentic AI.
Absolutely. The discussion emphasized our core technical innovations like persistent memory architectures, meta-agent orchestration, and simulation-based planning, which together form the backbone of these transformative systems.
Right, and we also delved into the importance of programmatic prompt engineering pipelines and robust logging mechanisms. These not only streamline operations, but also enable dynamic error correction through causal inference, keeping the system adaptive and resilient.
And if I may add, it's like constructing a digital nervous system. Integration of LLMs with vector-based memory ensures that agents continuously learn from past interactions, much like how our own brains continuously adapt over time.
From a strategic business perspective, these innovations translate into tangible benefits. For example, reducing manufacturing downtime, optimizing supply chains, and ensuring regulatory compliance through transparent audit trails, which builds trust in both tech-driven and traditional sectors.
Exactly. Real-world case studies, such as the global retail chain that reduced stockouts by 20% and manufacturing firms fine-tuning production rates, show that these advanced systems aren't just theoretical, but deliver measurable improvements in efficiency and risk management.
The take-home message is crystal clear. Agentic AI presents an end-to-end solution that seamlessly marries rigorous technical frameworks with transformative business outcomes, empowering industries to be more agile, precise, and forward-looking.
And while challenges like emergent behaviors and scaling complexities remain, our roadmap, highlighting RAG, tool-augmented reasoning, advanced memory architectures, and governance-aware designs, offers a promising path forward.
I might throw in an unexpected twist here. As Einstein once said, imagination is more important than knowledge. And in our case, it's that very imagination which is driving practical, innovative solutions in the AI landscape.
Thank you all for this enlightening discussion. Today we've charted a comprehensive map from the technical underpinnings to the strategic business advantages of agentic AI. And I'm genuinely excited to see these advancements reshape our world.